Hello chemistry students, today we are going to do our final lecture over the mole, and we are going to be just doing a couple problems to review what we've learned and make sure that we're reading the problem correctly and making sure that we can calculate it right to get the correct answer. So let's start off here with our first question. It just says calculate the number of particles in 5.2 gram sample of copper nitrate. So you really have to look at what our given number is to start off with, look at what element or compound we're giving from the periodic table, and then look at where we're going. So it says calculate the number of particles. So right off the bat, when it says particles, you know we are using the 6.02 times 10 to the 23rd number somewhere along the line. If we look down here, this compound is an ionic compound for two reasons. I see a polyatomic ion, which makes it ionic, and I also see an oxidation number. So we know this is going to be a formula unit. Here's our given number, okay? And then we need to find the formula for this, so copper, and it says it has a +2 charge, and then nitrate's NO3, and it has a -1 charge. So we know we're going to have 2 nitrate molecules and 1 copper atom to make this correct. So let's go ahead and do the dimensional analysis on this. So we would start out with 5.2 grams because that's our given number. And then we always write your full units, so grams of copper nitrate. Okay, and we're going to put that on bottom right away. So we're going to put grams of copper nitrate on bottom. And then we're always going to put 1 mole on top of copper nitrate. And the only place we can get grams is if we calculate it using the periodic table. So we can do a little side problem over here. Copper is 63.546 is copper, and there's only one of them. And then we have 2 nitrogens because that 2 goes to both. So it would be, nitrogen would be 2 times 14.0067. Oops, 067. And then we have 6 oxygens. So that would be 6 times 15.999. So let's go ahead and bring up our calculator. And we have 6 times 15.999. It's going to give us 95.99. So let's cross that out. And then 2 times 14. So we clear this and do 2 times 14. Oops, 14.0067. That gives us 28.0134. Cross that guy out. And I'll just add these three numbers together. So 28 plus 95.994 plus 63.546. That's going to give us 187.55. 187.55. That's the only place you can find grams. And then our last conversion factor, we're going to put moles on bottom so that these cancel out. And write out your full units here. And since we're trying to go to formula units, we put 6.02 times 10 to the 23rd formula units. Okay? And now we can just go ahead and calculate this through. Let me erase this molar mass right here so we have room for our answer. Okay. Bring calculator one more time. So we're going to take, clear this, and we'll do 5.2 divided by 187.55. And then we're going to multiply that by 6.02. Give us 0.1669. 0.1669. Okay, of course we have to put this in correct scientific notation. So we're going to move this over 1. Remember the units are 10 to the 21st right now. So our final answer, we need 2 sig figs, is going to be 1.7 times 10. Since we made this guy a bigger number, we make this one smaller. So it's going to be to the 22nd formula units of copper nitrate. Okay. So I really want us to not only review how to do this dimensional analysis, but be able to figure out what we're doing from the problem here. All right, our next one is calculate the mass of a sample of 2.733 moles of francium. Okay, so this one we're going to be looking for mass in grams. So we know that we're going to have to probably use that molar mass conversion and use our periodic table to find that. And we see that our given number is in moles, and that our what we're working with is just an element. So we're not going to have to calculate molar mass by adding things like we did over on this first one. So let's write out our given number. So 2.733, and we want to write out units, moles of francium. Okay. So on the bottom, we're just going to always just transcribe whatever that says. So it says moles of francium. And always what goes in front of the mole is 1. And then since we are going to mass, we put mass up here because we can put mass over moles. Okay. So this is only a one-step problem. So we look at francium here, and it's 223 grams of francium. And we're done because moles cancels out, and what we were looking for was mass, and we're at mass. So it's just 2.733. So we'll clear this. 2.733 and times that by 223. And so we get 609.46. 609.46 grams. And our smallest significant figure would be 3, so I wouldn't put this in scientific notation since it's only 10 to the second. So I would just say that this would be 609 grams of francium. Okay. All right, let's go ahead and do our next one. This one we're calculating the volume. So we know that's going to be in liters. And so we know that that 22.4 is going to be that conversion factor that we use. Carbon monoxide is a covalent compound, so we can just go ahead and write that as carbon and 1 oxygen, so CO. And it tells us the mass. So here's our given number. So we have 65.9 grams of CO. And we're going to put grams on bottom. And the only way we can find grams is to use a periodic table, so we can bring up our calculator since there's only one of each. Clear it. We know oxygen is 15.999, and we know that carbon is 12.0111. And you get 28.101. And we know that 1 mole goes over that because it's grams per mole. That's one of our conversion factors, moles of CO. And we're trying to get to volume. Okay? So now we know what 1 mole goes on bottom of CO. And now we can use this conversion factor of volume. So we know 22.4 liters of CO goes on top. Okay? So now we get out our calculator one more time. And we're going to take... Let's clear this, 65.9. We're going to divide that by 28.101. And then let's multiply that by 22.4. Okay, so this means that we have 52.53. And here grams cancels out, moles cancels out, and all we're left with is liters of carbon monoxide. Okay? Alright, I'm going to do one more for you here so that you can continue to study for your test or do your review sheet, whatever one you're doing tonight. And let's calculate the molar mass of this unknown compound. So this one is a little bit tricky because we're using these derived units, which just mean that the units are divided by. And anytime we have a derived unit, we can put whatever the one that doesn't have the number with it, we can just put a 1. So this is the same thing as that 17.6 grams over 1 liter. And we would go ahead and put our volume conversion factor over here. So we do 22.4 liters on this side over 1 mole. And the reason this works is because grams per mole is what, when we calculate molar mass on the periodic table, that's what it's called, grams per mole. So when liters cancels out, we're left with grams per mole, which is molar mass. So if we just take 17.6 and multiply that by 22.4, we're going to get 394.2. Okay, and then we could look on the periodic table and we would know that this element doesn't actually exist because the molar mass is way too high. But if we did have one that maybe was 194, we would know that that element was probably in the B block, maybe platinum, maybe an isotope of platinum or something. So this one, it doesn't exist, so maybe discovered a new element or something. All right, good luck on your test and study hard. Have a good night. I'm getting kind of used to it now.